In a computer adaptive testing framework, the items of the test are assigned to each respondent in an optimal sequence, so each item is selected as the most useful or informative at the current step of the test. So you complete an item, and then the test gives you the next item with the greatest amount of info at the current point estimate of theta. CAT uses the IRT framework and is able to converge on a person's ability accurately and quickly. It's also more robust at assessing different levels of the theta domain. So I'm actually going to run a CAT in R, and my generated data are from an open-ended test I gave my employees after a training and development course. And so I first install the necessary packages and I library them. The package is CAT-R, which is used for the generation of response patterns under computer adaptive testing. I then create my item bank. Right here is the step. And it has 500 items using a 1PL model and the seed default value of 1, which means the seed value is fixed for random generations at 1. I then create my specifications for the CAT model. And so the start one is the first one I do, and this just says that the test will start with the item that is most informative for the true ability level of 0. So that's why theta equals 0 and in our items equals 1 means that this is the first item that will be used. I next do the test condition, and test defines that the next item will be selected using the Kullback-Leibler divergency criterion, and the add interim ability will be estimated using the Bayes modal. So the Kullback-Leibler divergency criterion, which is a mouthful, is actually weighted by the likelihood function, and it's an item selection rule. And the Bayes modal method is used to estimate the ability level of an examinee given the fixed item parameters and the corresponding response pattern. So next I do the stop condition. And the stop condition tells the model when to stop giving the user any more items. It is defined to set a precision criterion for stopping the test when the standard error of the add interim ability estimate becomes smaller than 0.3. So that's why the threshold THR equals 0.3. And then the final condition down here tells the model how to estimate the final ability score. And so it will be estimated using the traditional maximum likelihood estimator. So now I have all of these, but first I'm going to check and make sure my data was correctly defined and created. And so head just looks at the first row of the generated item bank. Now I'm going to build my model to run for CAT. And so it uses the random CAT, which means it's randomly generating the items, true theta of 1. And so it is using the ability level of 1, and this is because I'm running a 1PL. And then it also uses all the conditions I defined above, so start, test, stop, and final. Now I'm going to run the model, and that's what this is right here. And it's the output, and so the test required 42 item responses right here to reach the pre-specified level of 0.3 precision in the ability estimation process. Note that the final SE value right here of 0.314 is larger than the requested threshold, and the final theta is actually at 0.592, which is a little bit farther than we'd like from the true underlying ability level of 1. The last time I ran this was 1.024, so that's what you'll see in my output I'm turning in. So next I'm going to create a model with simulated respondents, and this allows me to see how the different respondents would actually respond to this test if they were given it. So the model uses the thetas condition that I create to include 20 simulated respondents with true ability levels equally spaced between -3 and 3. So that's what this is right here. And this is when I actually create the model. So theta is equals theta. We're simulating the respondents. The item bank is the same as before. The model equals null because it's a 1PL. And then we use all the conditions above. I'm actually not going to run these the last 3 ones for you, because my session aborted after my 8-minute video last time. So we're just going to go up and see that right here is where I actually ran it. And it's looking for a true ability of 1. This is actually res, excuse me, I'm sorry. It has not been run because it's a new one. So we're going to run it because it got terminated. But here's the plot over here, which is what we're going to talk about while this is running because it does take a while to run. What you can see is when I make it bigger, it's actually very interesting. As the ability, alright, we're just going to keep going. As the ability, because this is the second time, as the ability is lower, the estimated theta is lower. And as it gets higher, it's higher. Test length is under 42 for about, let's say, 5% of examinees. But then when we get to about 80 and above, they actually take longer. And so, as you could have seen over here, which is in my output, sorry, Stephen, the test time was between 35 and 65, I believe. Conditional test length, most of the people who had -3 were taking longer, and then people who were actually up on the high end of theta in 2 or 3 took longer as well, while the ones between, say, -2 and around 2 were actually taking a shorter length amount of time, especially those who were a little below 0 were taking the shortest. And then item exposure rate was higher for those with the 0 theta. And I'll say that this, just kind of to wrap it all up, the model using the simulate respondents function was to see the output of the respondent simulation showing the summary statistics on the whole set of simulated patterns. The simulated respondents function allows easy simulation of a large number of CAT administration and provides both statistical summaries and plots regarding accuracy and item exposure control for the overall sample of examinees. And you'll see that it actually, there was 20 simulators that I looked at, and it gave us 10 people in the 10 response patterns, excuse me, in the output. And there's 2 simulators for each response pattern. And since I can't show you here, I'm actually going to see if I can pull it up real quick for you in my output. So this is where we have D1 through D10, and there's 2 simulators for each one. And it shows you the mean test length. So for the mean theta of -2.8, they took about 55 minutes to take it. But then those who did the best took about 61 at a 2.842 theta estimate. And then those in the middle were quicker, as you can see. So once, like I said before, longer times on the 2 outside of ability, the higher and the lower. And then we also can see the mean standard error associated with the theta. And then we see how those who did worse, how they are, and then those who did better. Sorry about this failing twice. But here we go. Also, something about exposure rate. The minimum, there was 194 items, but there was one that reached the maximum exposure rate, which means that it needed to go into another bank and wait to be used in the future because it had been seen by too many respondents.